Great. So if you already have the data set and the software, we'll navigate to the next part. So that's just introduction about what we are trying to do by using the VMD. So the visualizing molecular dynamics and atomic structures are useful for creating the 3D renderings of the atomic and molecular structures, and it could be used for the various in various majors like the chemical engineering and chemistry to understand the chemical structures and find some scientific information about those structures or those molecular dynamic simulations. The general idea is that if you think of the data that we have about the molecular structures, for example, let's say we represent a molecule by the atoms, the type of the atoms that we have in that molecule, that you can just think of it as a list of the atom types, and then a connectivity matrix that just say that which atom is connected to which one. So it just you can think of it as a matrix that shows which atom is connected to other one. And you can just think of it as a table of numbers. And then we try to create a 3D rendering that we could just see here from that table of numbers to just have a more visualized insight about what is inside that molecular structure, not just looking at the tables, which is really hard to understand what's going on. And throughout this workshop, we have two different type of data set that we will work on. The first one is just a simple static chemical and atomic structures. It's just a simple molecule, for example, that doesn't change over time. But the other one is called the dynamics, which is just the simulation, the results of the molecular dynamic simulation results that we have some changes over time, or the position of the atoms would change over time. So those are the two types of the structure that we will use throughout this workshop to create the visualization. So that was just a brief introduction of what we are trying to do or accomplish by using this VMD or visualizing molecular dynamics software. If you have any question or comment up to right now, so just let me know. If not, we'll just move on to the next section. Okay, so so if you opened already the VMD software, you should see two windows here. The one is called the VMD main, and the other one is the OpenGL display. So the first one, this VMD main, is about, for example, loading or importing all the molecular structures, and all the commands that we are trying to use throughout this workshop are located here in the VMD main. But the OpenGL display just shows the rendering or the 3D rendering that we are trying to create from those molecular structures. And also, sometimes it's useful to look at what's behind the VMD, because initially the VMD is just the command-based or the terminal-based software that you can just do all the operations or the commands by just typing the commands, but we are not going to go through that because that needs some TCL programming. So we are trying to just stick to the graphical interface for this workshop. But a brief introduction about what's behind is that if you just run the VMD, just show you some information in the terminal, and you can find out some information about what hardware is available in your machine. For example, in this computer, I have 4 CPUs that those 4 CPUs would be used for creating the rendering, and that would speed up some of the renderings that we are trying to do. And also, I don't have any NVIDIA GPU on this computer, and I have an Intel graphic card. But if you have some NVIDIA GPU, that also could be used to speed up your 3D renderings for creating the visualization and create visualization from the much more bigger molecules. For example, in this computer, I cannot go beyond, for example, the molecules that have the atoms, for example, beyond maybe 100,000 atoms. But if you have a more powerful computer, like for example, using the Palo Alto cluster, that you have the GPUs that you can just go to molecular structures that have maybe millions of atoms or even bigger structures. So that was just the introduction of what generally the VMD 2 type of the windows that we have. So let's try to open a new molecule. As I said, everything that we are trying to do as the operation or executing the commands are located in the VMD main. So if you want to open or import a molecule, you can just go to the file, click on the new molecule, and click on the browse, and try to find the file that you downloaded. And open that one. It's called the 1ubq.pdb file. The PDB files are the ones that are specifically designed for the proteins or the biomolecular structures. So we just have them already downloaded from somewhere, and then we could just click on open. And one thing you might notice is that the VMD could understand or find the file type automatically here. It just found that the file that I tried to load is the PDB file. But sometimes if you have a really maybe special file type, you may want to just specify your file type here. For example, if it's Gaussian simulation results, GROMACS or LAMS or even other molecular dynamic simulation software results, you can just specify that from the list of the file type that you have here. And also here for the frames, because as I said, it's just the static, it's just the first type of the molecule that we are trying to use, and then we'll move on to the molecular dynamic simulation results. But for now, because it's just a static molecular structure or just a one snapshot, the molecule doesn't change their position. So you can see that I don't have any frame here. So, but in order to make sure that you loaded the molecule, don't forget to click on the load. That would just eventually load the molecule for you. So if it's loaded successfully, you should see this 3D rendering here in the OpenGL display window. So up to this point, any question, any error, any comments that you might have?
Sorry, I got a quick question. So I load this PDB, so as you demonstrated just now, and load this 1ubq PDB file. Then shall I just say the same thing as you showed in this small window? Since I just drag this window and it's become totally red. So this window filled up the just red colors. So, do you any idea why it's like that?
You mean this window that you have here in the OpenGL display is completely red and doesn't show the molecular structure that we are seeing here?
Yes.
What's the graphical card of your computer? Is it the NVIDIA GPU or it's Intel graphical card?
Let me check.
You can just, if you have, I'm not sure if you are in the Mac or Windows machine, but if you are in Mac, definitely you can just check. Or also in the Windows, I believe that there should be a terminal that you can check your OpenGL renderer here. Do you
Okay,
have?
yeah, I'm using Mac. Let me see. OpenGL is so it's using, I think it's graphs AMD. Maybe it's kind of old. I'm not sure. Yeah, it using, yeah, maybe a graph card, AMD card.
That's AMD card, but so maybe I'm not sure if the let me see, because I remember the VMD has a special version for the AMD. Let me check that. So that's ARM. Maybe I'm not sure. Maybe you want to just uninstall the current version and download and install the latest version to see if that would resolve that issue. But other than that, my guess is that it has something to do with your graphical card, maybe, because that just shows you some a red window. I'm not sure, but we can just give it a try to just install the latest version to see if that might resolve the issue or not.
Okay, okay. I will try that. I think installation won't consume much time. Thank you.
Okay, thank you. Any other question or comment, or if anybody else has also similar issue with with the rendering here? Okay. So the next step is to change the graphic representation of the molecules. Right now, the one that we are rendered here automatically is just simple lines that just shows the bonds between the atoms. But in order to change the representation, you can just click on the graphics and go to the representations here. And we could change the, we could have in the selected molecule first, if we have multiple molecular structures, we could just have them as a list, because maybe you just loaded a lot of different molecules at the same time. Even if it's just a static structure, you can just see your list and then choose which one you want to just change the graphical representation. And also you can just have multiple representation of a single molecule. So here you can just create multiple representation or delete any representation. If I just delete that, that would just delete the one that I have already, and I can just create multiple ones. So those could be just this same molecule, but different graphical representation for the rendering. And also the selected atoms here is that we just selected all the atoms, but it's possible to select some specific, for example, regions of the molecule or some specific types of the atoms. For example, let's say I want to select only the water molecules in my structure. I can just type here waters, but for now it's just all the atoms or everything that I have in my molecular structure. And the coloring method is that what we want to use as the coloring of the atoms and their boundings between the atoms. So here is just the default is just to use the name or type of the atoms. But for example, if you have some information about, for example, let's say the sequence name, chain name, or residue ID, residue types. You can just, for example, change that to something else. That would just change the coloring method. And also the drawing method are the different type of the rendering mode that we have in the VMD. Right now, it's just a simple lines that just show you a line between two atoms as they're bounding. But for example, we could have the one that might be more familiar for showing the atoms as spheres and the bounds between them as a cylinder, or this one that just show you the spheres as the uh, atoms. Or sometimes for the biopolymers or the polymers, maybe we want to use the tube or ribbons to just show the backbone of our structure, because this one is the protein and we have some kind of the backbone here. So, but if you want to just have more complex representation, you can just create multiple representation, and the other one doesn't need to necessarily to be the same as the first one. For example, I could just change that and possibly put this one here. And you see that I just combined two different representation here. So one is just the ribbon and the other one is this that CPK. So I just combine these two different representations together. And still I just use the different coloring type, and the selection is still is all for both of them, but you can have different selection or coloring type or a style for any representation that you create for a single molecule. That could just give you ability to combine some of this representation together and create a visualization that shows that molecular structure. Any question or any comment or any issue that you might have until here? Okay, so the other one that I said that we could just right now, we just use all the atoms here. But for example, let's say we want to just show the backbone or any other type of the selection that is already available in VMD. You can just select that and remove the all and just use, for example, the backbone here. You can just have also multiple ones. So you can just have as many as you want. And also there are some default selection available. Each word or each key here in that list represents a predefined selection in the VMD software. But it's possible to create new selections by using the TCL programming that we are not going through that in this workshop, but it's also possible that you want to create some customized selection for yourself based on the type of the selection that you want to have for your structure by using some TCL programming. Any question, any comment here? Okay, and also sometimes for example, for the crystalline structures that you have some periodic structures that you just use the visualization for a single unit cell of that periodic structure, and for just showing the periodicity, you want to just show that it's just repeated in some different direction. It's possible to create the images in the different directions. For example, creating some images in the X, Y, or Z directions. and how many times that I want to just create that. Right now it's just one. I can just make it two, that you see that it just create those images for me. But remember that it would just create a copy. It doesn't create a real periodic structure. It just for showing, for the sake of the visualization, just copy an image of the existing representation to a different directions that you have. So that would be good for some visualization of some crystalline structure, that you have some periodicity, that you can represent those periodicity by using this, creating the periodic image in the VMD. Any question, any comment? Okay, so the other parts are about creating the, let's say if we created this visualization and right now we want to just save it or create a snapshot of this visualization into the disk. And in order to do that, we could just go to the file and go to the renderer here. And we could just specify our renderer. Right now, the default is just using the OpenGL snapshot rendering. But if you have, for example, the PowerArray software, which is just another software that you need to install in your machine and use that for the rendering, you can just use that rendering engine for creating the snapshot. And also, you can just specify the file name and the location that you want to use for the rendering. Let me just, for showing that, let me save that here as a dummy. You can just specify the name here, and then click start rendering. That would just create a snapshot of what you are seeing in the rendering window. It just saves that snapshot into a file. But for more high quality rendering, you might want to just use the other engines that you need to make sure that you have. Some of these engines need some other softwares that you need to install on your machine. So you need to make sure that you have all the dependencies of these rendering modes to make sure that you can just use that rendering. So if you click on the start rendering, that would just save that file into the file that I specify as the dummy or whatever, and then you can just have that rendering here. It's not the best quality of the rendering to use the one at the OpenGL window, but for now, because I don't have any other software like the PowerArray or other rendering engines, so I'm just using the one that is the default of the VMD software here. Any question, any comments? And finally, it's possible to do some modification to the background color, or for example, changing the background color, changing the display of the axis or whatever. So for example, here, if you click on the graphic and go to the colors, so it's possible to choose the display, for example, choose the background, and instead of black, you can just, for example, choose white. That would change the background color, but you can just customize other parts. For example, here my x-axis is red. For example, I can just change it to, for example, let's say orange. You can see this, it just turn to the orange, or just change all the colors and the representation that might be just useful for final snapshots or the final 3D rendering that you are trying to create here from your molecular structure. So those are just the ones that you can just tweak by yourself and explore that what's available here to just and also, for example, let's say if you want to get rid of, sometimes it's possible to get rid of this axis here, because sometimes you want to just show that which these molecular structures are oriented along different directions. But sometimes you want to get rid of the axis, so we can go to the display axis and turn it off completely. So it would just turn off the axis, and then you can just, if you want to just bring it back here, you can just put it somewhere here. So those are the small changes that you can just tweak the final visualization that you created for your molecular structure, and then save the snapshots, the final snapshots of your visualization. So with that, I think we finished this section here. Any question, any comments about this section or any other previous sections that we have?
Yeah, I still got a quick question. So could you please just show again how to like get rid of this axis in this window?
For getting rid of this axis, you can just go to the display here, go to the axis,
okay,
and turn it off.
Oh, I see.
Yeah,
I see. Thank you.
So just turn that off here. But if you want to just bring it back for some reason, you can just, for example, put it somewhere, but I would just want to put it lower left. I would just put it lower left here for me. Yeah.
Okay. Okay, I got it. Thank you.
Good, thank you. Any other question or any comment? So in the next section, we will try to open a molecular dynamics simulation results that we have different snapshots or the time dependency. So I'm trying to close the VMD software and reopen it again for having a clean opening. So I'm just edit. So in order to load the molecular dynamics simulation results, first we need to load the molecular structure files that we have in that folder, which is called the ubiquitin.pcf. That's just a single structure that we have. And again, we will go to the new molecules, go to the browser, and go to the download or whatever location that you have that file. And try to open this ubiquitin.pcf file to make sure that you load that. And also then we load the movement, which is called the pooling. DCD. So one thing to notice is that make sure that it's not set on the new molecule. So I want to attach that movement or this file called the pooling.dcd to the ubiquitin PCF file that I loaded previously. So make sure that it's load files for the ubiquitin PCF. So not a new file. So if it's loaded successfully, you should see this one. And also in comparison to the one that we had before, you see that we have 100 of frames here. So that means that we have time dependency for this molecular structure. And we can just, for example, look at the different snapshots here. We have 100 of different snapshots. We can just look at the different snapshots quickly by just dragging this option here at the underneath of this VMD menu. And also you might want to just show it as a loop. It just could show it for you for the loop, and you can just say that the step between each frame, that is 1 here, but you can just change it to 2 and just specify the speed of this one, and then you can just maybe click on here. That would just, so that's the one. And also if you just put it on the once, it just would go to the end just one time, but the loop would just go forever. You just loop. Any question, any error, or any comment that you might have to load this molecular dynamic simulation result here?
Yeah, so you mean first to load files, which one? I couldn't find this.
If you downloaded that zip file and open that, there should be this file called the ubiquitin.pcf.
Let me see. I already downloaded that zip file, but I don't know why I cannot find this PSF file.
So let me see. Let me just close this and remove my. I'm just going to close this and also remove the one that I already downloaded to make sure that you have that. So that's the one. I'm just going to put this into the trash. That's the VMD tutorial file. Trash. And let's open the first one, the very first one. So just go here, click on the data set.
Yes, yeah, I got this one.
And download it anyway. So I'm just opening that zip file that I downloaded already. And if I open that, there we go. We should have the ubiquitin.pcf and the pooling.dcd file.
Okay. Yeah. Let me see this. Oh, Okay, I saw it. Ubiquity PSF file. Okay. So I just load it, right? Open it.
Yes, we should have that file in the VMD tutorials files folder.
Okay.
Do you have it right now?
Yes, I found it.
Okay, great. So let's come back to the VMD. I'm just going through that again really quick. Go to the file new molecule, find the ubiquity in the PCF file. It's this one. And I'm going to then load the pooling.bcd file and make sure that it's loaded for the ubiquitin.pcf, not a new molecule. So make sure it's not on the new molecule, it's on the ubiquitin.pcf, and click on load. Then you should have it on here.
Okay, well, sorry, another issue. So, so what's the type for this PSF file? So I just default it's the charm named
Yes, yeah.
the trajectory. But when I try to load this, it gave me a new window, told me unable to load this molecule.
That's interesting. Let me just load it from scratch again. So if you follow this step, that should be fine, I believe. So because we tried it on the different versions, so that should be fine. So
Yeah.
the first step to click File, New Molecule, click on Browse, click on Download. Click on the ubiquitin.pcf file and click Open.
Okay.
And you would find the file type as the charm NAMD Explorer PCF. You can just click on Load here. You don't need to change anything. Then again, just click on Browse. Look for this pooling.bcd file here.
Okay.
And click Open. Again, if you find the file type as the charm NAMD Explorer DCD trajectory, these are the trajectory files. And then you can just, you don't need to change anything. You can just click on Load. And then that should load the structure and the trajectories for you.
Well, yeah, I just stuck at the to load that PSF file. Yeah, when I try to load it, yeah, I do download that zip directory, and I can also see that PSF file, ubiquitin PSF. And when I try to load it, and I also I didn't change any other setup, but when I just try to load it, it showed me unable to load molecule.
Can you go back to the terminal here and see if there is any error, because every error should just appear in this terminal.
Okay, let me see. It showed me unrecognized DCD header, unrecognized file structure. Yeah, arrow. It's weird. Okay. I have no idea why this. Yeah, and the version for this VMD. Just now I downloaded the yeah, the version for this Mac, I think. Yeah, and it's also the latest one, 1.9.4.
That's interesting.
Okay. Well, I think you can go ahead first. Let me search it whether what's yeah what's wrong with these things.
Also, you can just maybe send the error message to my email. I also would look up for that later on after the workshop to see what's wrong with that.
Okay.
Thank you.
Okay. Thank you.
Okay. So if you loaded that molecular structure, that should be fine here. Then we will create a really quick representation like the one that we had before. We will go to the representation and so first we will put, for example, we could just put the drawing method to the new ribbons and the coloring method to the residue types. And for the selection ones, I don't want to just have the water because those molecules that you saw initially around that molecular structure, those are the water molecules. So I want to just eliminate any water molecules and then create a new representation and change that to chain. And I could just change it to the surf here. And make it transparent. The transparency just could just overlay two different representation together. In the material, you have lots of different material or the texture that you can just put on your 3D rendering. The opaque means that you don't see the inside here. Let's see. This is the opaque structure here shown, but the transparent, you can just see the other representation inside that molecule. So that's the one I would create for this molecular structure here. And after creating your representation, because this is a molecular dynamic simulation result, we want to create the 3D animation. We could go to the extension visualization here, go to the extension visualization and movie maker. And could set up our working directory first to just make sure that where we want to save our animation file. And the name of the one that I could just put the dummy movie or whatever. And the format, you can just change the format if you want to have it as a GIF file or the JPEG, the Targa or any other formats that you have here. But for some of them, you need to have some other softwares installed like the FFmpeg. Also, you can just specify the format. And also, if you click on the movie settings, you can just specify the format that you want to use for generating the animation. The first one, the rock and roll, is just change the camera for you in a XY direction. But sometimes you want to just, because this is a molecular dynamic simulation results, that we want to create the animation from the actual frames or the trajectory. So we can just put it on the trajectory here. And also, because the way that it creates the animation is that it just created lots of image files and then it tries to combine those image files together. But if you don't have, for example, the image magic or the FFmpeg, it might be good to just don't delete image files, to have those image files, and then use another third-party software to combine those images together and create a GIF file. And some other information, for example, if you want to create the animation from the trajectory, the step that you want to just go through the trajectory frames is one, or you can just change it to whatever. And also specify the duration of your movie, 4 seconds or any other one. And then you can just click on the make movie. That would try to save the files for you on your machine. So if I go into my download folder, I should see lots of different files created here. So you see that these are the files that is created by the VMD. And at the end, it tries to combine these files together to create an animation, but I don't have the image magic on this machine. So if I want to just have an actual animation from all these frames that are saved in my computer, I need to just use a third-party software to just combine all these snapshots together to create a animation or movie. Any question or any comments? So at the end, we should have this similar animation here, which is shown here by combining all those snapshots together. With that, we'll move on to the last section. So I'm just trying to finish this and open a new VMD to just go through the last section. So if you just followed all these steps, you can just maybe quit this VMD and then open a fresh new one to go through the last step or the last section of this workshop, which is doing some analysis or computational analysis of on the structure that we have. So for this one, for this section, I'm going back to load the one PDB file that we had initially. So I'm going to load that. Here, create the similar representation that we have here. Go to the graphic, create the representation. The new one, all the new ribbons, beta. Or just remove that. Okay, so the first part is to just find the sequence of the protein structures. There is a built-in plugin in the VMD that would find those sequence for you. So in order to access that extension or the plugin, we would go to the extension, analysis, and multi-sec. So I'm just choosing this directory, and it would try to download that extension. So I'm just clicking on OK. It would download some.
I'm sorry, just a quick question. So where is the extension that we're using now? Which tab is it in? Can you show it again?
Yes, let's try that. It's in the extension analysis multisig.
Okay, I see. Thank you.
Yeah. So maybe I just use the wrong place for saving all those files. I'm just going to remove that. And so we open a new one. Here, go to the extension analysis, multisig.
Yeah, I saw this error message as well.
That's interesting because let me remove that. Let me see. My concern is that maybe I just use a location that needs some sort of administrator privileges, which I might not have that here. I'm just going to remove that. So let's try it again. So we just ask to specify a location, and I'm just going to specify this download location. It's interesting if it's, yes, yeah, that was because I didn't have the, you still see the same error. Just try to find a location that doesn't need any administrator privilege to download or open any file in that folder. That might help. Some of the files that are not available. I'm not sure what's the problem here. Maybe that's just because of the latest version. I have here some of this might have. Let's see if it works in its current situation. Go to the extension analysis. Yes, it works. I think it's still just because it already finds the correct sequence of this protein structure. So make sure that you choose the folder that you have the privilege to write or read or open the files, and then you should be able to just use this multi-seq plugin to find the sequence of the proteins. Any question? Any? The other one is the other plugin that we'll introduce here is finding the contact map of the biomolecules and the proteins. So in order to find the contact map, we could go to the extension analysis and click on the contact map. Here and click on why it doesn't show the correct one. So just click on the residue distance for the calculating the contact map. Then it should just show you the contact map of this molecular or protein structure. I would just show you, it just calculate the contact map based on the distance between the different residues in this protein. Any question, any comments about this section? And the last one is finding the hydrogen bonds for the molecular dynamic simulation results. So for that, we may again close this one and load the one molecular dynamic simulation results that we had and try to calculate the hydrogen bonds here. So if we go to the file, new molecule, look for that ubiquitin file. This one and the pooling DCD. And in order to calculate the hydrogen bonds, we go to the extension analysis hydrogen bonds. And in the input section, choose the molecule that we want to use for the calculating the hydrogen bonds and specify the donor acceptor distance. And click on the find. That should see the number of the hydrogen bonds in different frames of the molecular dynamic simulation results that we have. So that would also create the calculate the number of the hydrogen bonds versus the time or the number of the frames that we have in simulations.
Excuse me, I have a
Sorry.
question.
Sure.
Yeah. So, can you show the settings of the hydrogen bonds? Because after I click the find hydrogen bonds, there's like nothing shown up in.
I didn't change anything. It's just the default values for the configurations, but just make sure that you in the display, you see this structure in the display window.
Okay. Seems that I used the wrong structure. Thank you so much.
Okay.
I'll try with a new one.
Good. The last one that we'll go through is that calculating the radial pair distribution functions that might be useful for calculating some structures. So
sorry, I just have a very simple question. So
okay.
in the when you plot the hydrogen the per frame hydrogen bonds, so do you have to set anything to get those axes like frame and number of bonds? Because here I use the default settings and it's not showing the coordinate axis.
That's interesting. You mean you don't see this number of bonds or frames or these numbers in the axis, but you see the plot?
Yeah, I see the plot, but I just don't see the legends or the axis.
That's interesting because it should show you that by default. But let me see that if we have some. I'm not sure if we have access to even change that, or that's interesting because I'm not sure if we have any configuration to change that. That's just a default of the VMD. But it's interesting that you see the plot, but it doesn't show you the axis. So
yeah. So actually I'm using the one because I'm using the macOS 11. So actually I'm using one of the alpha testing versions of VMD. I don't know if this is one of the errors that's to be fixed. So I'm not sure, but I'm not using 1.9.3 or something because I'm using, I think they said it's a testing version. So maybe there are just some bugs in this version. Yeah.
I'm using the one that is here, the 1.9.4A51. That's also the alpha version. But
oh yeah, we are using the same version. Yeah.
That's interesting. But I also use the Mac here. But maybe installing some of the previous release version that might help. I'm not sure. You can just try that if that might help or not.
Okay. Thank you.
Okay, good. Thank you. So the last one is to create a radial distribution function. And just go to the extension analysis and click on the radial pair distribution function and choose the molecule that you want to use for the calculating that radial pair distribution function and compute. that all and make sure that is done for the proteins. So in the selection, you can just do the all or just do it for the protein that you have here. Protein and water. So put the protein and water in the selection 1 and selection 2. It's interesting. What's the error? Not sure why it complains that the unit cell is 0. Just check that PVC. Just uncheck that PVC, the first one. And oh, that's interesting, but close that. So let me open it again. So that was this one. And it's that one. Go to here. Water. And as far as I see, we don't need to change anything. For some reason, it just complains that. I think it's just a bug maybe in the latest version. So I think if you try on the previous version, that would just compute the radial distribution function. It just show you the similar plot that we see here for showing the position of the atoms versus the distance that we have in the radial direction. Any question, any comments, any?
Well, here I got the same issue.
Yeah, my concern is that maybe there is a bug in the latest version and we need to just use the previous version to resolve that issue.
Yeah, mine as well, actually.
Okay. Yeah, I would try to with the previous version and see how that works. Any question, any comments? With that, I think we finished all the parts for the introduction to VMD software. Just feel free if you have any question, just ask it here right now, or you can just always shoot me an email here in my email address. I'm just going to put my email address into the chat. Just feel free if you had any question regarding the VMD or any other visualization softwares, just feel free to ask your questions. Or if you have any request to have a specialized workshop for any software, we could try to work on that as well. Any comment, any issue, any question?
Yeah. So for now, yeah, I got older versions for VMD. It seems that if I use the older one, it works.
Okay.
Set up for radio functions. Now it's showing try to calculate this radio function. Yeah, it won't give us a window to do some extra operations.
Okay, so maybe just using the older version might resolve some of these issues. Yeah.
Okay.
Good, thank you. Any other question? Any?
I have a question.
Sure.
Can you hear me?
Yes, yeah, I can hear you.
I have a question on the hydrogen bond analysis.
Okay.
If we have multi-peptides in our systems, so will the both the intra-chain peptides and the inter-chain peptides be counted?
For that, I think you need to just select the relevant parts and then do the hydrogen bond calculation. So let's see what's available here. You can just select the parts that you want to use for the hydrogen bond calculation. So you might want to use the relevant parts for the selection and then do the hydrogen bond calculation.
So if I select the two peptides,
yes,
and
yeah.
The total number of hydrogen bonds, let me think. So will the inter-chain peptides be of each inter-chain hydrogen bond of each peptide be counted?
Right, I think so. Yeah, yeah. You need to just choose that. Yeah.
Oh, I see.
Any other question? Thank you. Any other questions or comments?
Sorry. I have another question.
Okay.
And for the contact map analysis, if we have many peptides in our systems, let's say 10 peptides, and each peptide have 10 residues. So the contact map will be a matrix of 10 multiply 10 or 100 multiply 100.
Right. Yeah. Yeah. That's great. Also, I believe that for the contact maps, if you, because we didn't go through the programming or writing the script for the VMD, you can customize the contact map by using some TCL scripts that you can just, again, choose some relevant parts of the molecules or even define what function that you want to use for calculating the distance or calculating the contact map. But we are just using the whatever that was already available in the graphical interface of the VMD. But for more customization, you might want to use the TCL programming, which is not in the introductory to the VMD. That's what that's the way. Maybe you can just find it in the VMD manual to just how to write a script for the VMD by using the TCL programming language. That could be used for the customization as well.
Oh, I see. Thank you.
Thank you. Any other question? Any comment or any issue? So with that, if there's no more questions, I think we just finished this workshop, and thank you for your participation and your attention to this workshop.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.